Hello students, welcome to the lecture. I hope you all are good and are taking care of yourself and your family members. We are going to study in this video lecture about probability and statistics, which is unit number 4 in our syllabus. In the previous conference call, I have already briefed you about this unit which we are going to study, probability and statistics. I have told you the importance of this unit. Let us glance through those points once again. Probability theory provide a formal basis for quantifying risk or uncertainty in engineering problems which are otherwise being dealt with qualitative approach using engineering judgments. I have explained you these points, all these points there itself in the video lecture last week. It is widely used in testing and reliability assessment of engineered system. Whenever we are given a task of testing a reliability of some engineering system, the probability is always there. Probability and statistics concepts are always there. There are many phenomena in engineering that cannot be accurately modeled computationally and will require testing in order to predict its performance. Right? Statistics, on the other hand, deals with the collection, presentation, analysis, and use of data to make decisions, solve problems, and design products and processes. Statistics also plays an important role, as important as probability as far as engineering is concerned. Any field of engineering is concerned, statistics, we are going to need statistics at any point of time. Engineers solve problems constantly and repetitively. That's why the need of statistics in the engineering domain is of huge value. Right? Let us talk about, in particular, electrical engineering. In electrical engineering, the use of probability and statistics is widespread. In digital signal processing, false alarm probability in radar, any noise calculation, designing networks that stay within space in face of component tolerance. So, DSP, false alarm probability, noise calculation and cancellation, designing networks, everywhere we are going to need these concepts of probability and statistics. Renewable energy sources like solar and wind are intermittent. What is meant by intermittent? They are not continuous. They are coming and going many times due to climate change. Forecasting studies are not accurate. So electrical engineers use probability density function. We are going to see what is probability density function very soon, to mathematically model the renewable energy source. So in electrical engineering, probability and statistics also plays an important role. It has a major role to play as far as electrical engineering is concerned. These are few examples which I have kept in this slide, but there are many examples beyond these slides, beyond these presentations. So what is your task? Your task is to search for those applications where probability and statistics is applied in your field of engineering. Okay. What are the contents that we are going to study in this unit? We are going to study random variables, discrete and continuous, distribution function and their properties, probability mass and density function, mathematical expectation, moment generating function and its properties, and then we are going to see some probability distributions. Bernoulli's, binomial, negative binomial, Poisson distribution, normal distribution. We are going to see theory of least squares and curve fitting, then correlation, simple regression lines and regression coefficients. This is the content these are the contents that we are going to study in unit number 4. What is the book that you are supposed to refer for this? I will suggest to go for S.C. Gupta and V.K. Kapoor, Fundamentals of Mathematical Statistics by S. Chand and Sons. Okay, so these are the contents which we are going to study in this unit number 4. So what I feel is the contents which are there on the screen are absolutely new to you. You have not seen these content, or you have not studied at least basics of these contents in your earlier classes, especially in 12th standard. Okay, for that, for going directly to this unit number 4, what I need is, I need you to equipped with some basic understanding of probability. So what I am expecting from you, from your earlier classes, from your plus 2 level, I am prerequisite. The next slide is prerequisite. I am expecting these things from you, right? Following are the prerequisites. That means things you should know before starting our actual syllabus, which you have already studied in your 12th standard. These topics can be taken from any standard book of 12th class. So what I am expecting, basic terminologies like random experiment, outcome, trial or event, exhaustive events, favorable events, mutually exclusive events, equally likely events, independent events, basic definition of probability and some basic examples, permutations and combinations, theorems on probability, conditional probability, independence and Bayes theorem. I suppose all of you, from whichever board you are, you have studied these concepts of probability in your plus 2 level. So what I want from you is, I want from you to go through these concepts again, so that before moving to this unit number 4 in our 4th semester of engineering, you should be equipped with all these things so that you can tackle any probability and statistics problem using these concepts. Okay, so the same has been discussed in the previous video conferencing session, and I hope you are now ready with all these things so that I can start the actual unit. So let us move to the actual unit. You can see unit number 4, the first topic is random variables, discrete and continuous, and then distribution function, their properties, probability mass function and probability density function. So I am starting unit number 4 with random variables. Let us focus. Random variables. A random variable capital X whose value is determined by the outcome of the random experiment. ओके, ये फिर से टर्म आ गई, आउटकम, रैंडम एक्सपेरिमेंट, जो इस स्लाइड में रखी हुई है. सो इट इज़ वेरी इंपॉर्टेंट फॉर यू टू study these topics which are very I should say preliminary in nature, which is very elementary in nature, so that you can understand the terms here in our actual syllabus. I am reading it again, I am telling it again. A random variable X whose value is determined by the outcome of random experiment. If you are performing any random experiment, then the value of it is called as the random variable. Okay, it is a value. Remember, it is a value. It is also called as stochastic variable. Example से कोई भी चीज़ अच्छी समझती है, especially probability में. Example is tossing of a coin twice. So what will be sample space? You are clever enough to tell that either both head will be there, one head, one tail will be there, tail head will be there, or tail will be there. So what we are going to do for random variables, we are going to define a function x. X is from this sample space S, which has 4 elements as above, and it is mapped to the set of real numbers by x of S is equals to number of heads. So basically what we are doing, we are counting number of heads when defining this function capital X. Okay, so random variable is nothing but a function. Then x of HH, how many times HH is coming? H is coming here 2 times, so x will be 2 in this case. What about x of HT? Head is coming 1 time here. What about x of TH? It is coming 1. What about x of TT? No heads are there, so 0. So what will be range of this function? Range will be 2, 1, 0. Though 1 is repeating, but set theory में repeat करने में मतलब है कोई नहीं. Set theory में हम लोग अगर कोई चीज़ repeat हो रही है तो उसको एक बार ही लिखते हैं. Okay, so random variable here will be the random variable, double quotes में random variable will be 0, 1, 2. So it is basically a value representing the outcome of the random experiment. Let us see one more example. Example is throwing 2 dice. This time what I am doing? I am throwing 2 dice. You know dice, right? You play Ludo or snakes and ladder using that dice, which has 6 faces, 1 number on each face, ranging from 1 to 6. So what will happen when I am throwing 2 dice at a time? I am going to note 2 readings at a time. So what will be sample spaces? What is the superset? What is the superset of all the readings? It will be either 1 1, 1 2, 1 3, or and so on up to 1 6. It will be 2 1, 2 2, 2 6. It will be 3 1, 3 2, 3, and so on up to 3 6. It will be 4 1, 4 2, and so on up to 4 6. Similarly, it will be 5 1. Similarly, 6 1, 6 2, 6 5, and up to 6 6. So this sample space is given here. So what I am going to do, define a function x from S to R. Similarly, previously also I have done the same thing. I am defining a function x from this sample space to set of real numbers by x of S is equals to sum on 2 dice. So what I am going to define here, how I am going to define this function here, x of S is equals to sum on 2 dice. that is x of I comma j is equals to I plus j for every I comma j belongs to sample space. So you know sample space में टपल के रूप में आपको हर एक एंट्री दिख रही है, जैसे 1 1 1 2, राइट. सो 1 इज इन 1 2 1 comma 2 आई हैव i is equals to 1 and j is equals to 2. सो आई एम डिफाइनिंग अ फंक्शन कि उनकी एडिशन कितनी आएगी. ओके, देन व्हाट विल बी एडिशन, देन एक्स ऑफ सैंपल स्पेस कैसे दिखेगा, सॉरी इसका रैंडम वेरिएबल का सेट कैसे दिखेगा, एक्स ऑफ एस विल बी 1 1 + 1. इससे छोटी एंट्री आएगी, 2 से छोटी एंट्री आएगी इसमें, बिल्कुल नहीं आएगी, क्योंकि सबसे लीस्ट एंट्री इज 1 1 ओनली एंड 1 + 1 is 2. So next entry is 1 2, so 1 + 2 is 3 4 5. What will be maximum number here? The maximum number here will be 6 6. So I am going to take 6 comma 6. So in that case I am going to take 12. So sample space will be, the random variables will be x of s is equals to 2 3 4 5 6 7 8 9 10 11 12. Okay. So in this case we define random variable. In this case random variable is determined by the outcome of the random experiment. All right, fine. Right, then random variables. So random variables, we have seen how it is defined actually. When random variables, what are the types of random variables? Let us see what are the types of random variable. Random variables are of two types as following. What are the two types of random variables? Random variables, it may be of discrete type or it may be of continuous type. So basically random variables are of two types. One is called as discrete random variable, DRV, and the other one is continuous random variable, CRV. So in this video lecture I will be totally focused on DRV, discrete random variables. Okay, and in the next class I will tell you what is continuous random variable and its subsequent properties. Right, so let us move forward. Discrete random variable. Okay, so I will be totally focused on discrete random variables as far as this lecture is concerned. A random variable x which can take only a finite number of discrete values in an interval of domain is called as discrete random variables. I am reading it again. A random variable x which can take only a finite number of discrete values in an interval of domain is called as discrete random variable. Okay, so if a random variable takes the value in the set 0 1 2 3 and so on up to n, then it is called as DRV. अगर हमको discrete values मिल रही है, मतलब हर एक आउटकम के लिए या फिर हर एक फंक्शन डिफाइन करने के बाद हर एक आउटकम के लिए हर एक नंबर आ रहा है, जैसे पिछले केसेस में आ रहा था जो आपने देखा, टॉसिंग ऑफ कॉइन ट्वाइस, थ्रोइंग 2 डाइस एट अ टाइम, इसमें हर एक इवेंट से एसोसिएटेड एक नंबर आ रहा था क्योंकि हमने फंक्शन उस तरीके से डिफाइन किया था. सो अगर इस तरीके का केस आता है तो हम उस रैंडम वेरिएबल को डिस्क्रीट रैंडम वेरिएबल बोलते हैं क्योंकि उसका आउटकम हमको डिस्क्रीट फॉर्म में मिल रहा है. Example is, yes, repeating, throwing a dice. When you are throwing a dice, it will be 1, 2, 3, 4 or 5. Tossing a coin, when you are tossing a coin, it will be either head. If you are defining it as a head, then head will be 1. If you are and tail will be 0. If you are defining it as tail, and if tail comes, then it is tail is 1 and head is 0. So a number is associated, discrete number is associated as far as that experiment is concerned. Number of defective bulbs from a bag full of electric bulbs. नंबर ऑफ डिफेक्टिव बल्ब्स, उसको तो ऑब्वियसली नंबर में ही रहना पड़ेगा. कोई ऐसा बोलेगा कि मेरा 2.5 बल्ब्स खराब निकले. नो, इट विल बी आइदर 2 और आइदर 3. इट विल बी अ नंबर, इट विल बी अ डिस्क्रीट वैल्यू. So these all three are the examples of discrete random variables. Okay, let us not think at this time about continuous random variable. I will explain it in the next class. So just focus on discrete random variable. If a random variable takes values only in the set 0 1 2 3 and so on up to n, then it is called as discrete random variable. Okay, it should take finite number of discrete values in an interval of domain, not infinite. Right? Random way. The probability distribution function. I think this concept is new to you. What is probability distribution function? The probability distribution or just distribution function associated with random variable x is the probability that the outcome of the experiment will be one of the outcomes for which x of that E sample space S is less than or equal to some small x for every x belongs to R. That is how the probability distribution function is defined. Fx of x is equals to P of x, the random variable, less than or equal to some limiting value, some limiting real value, is equals to probability of that sample space S such that random variable at that S is less than or equal to some limiting value in the interval minus infinity to infinity. It is called as distribution function. ओके ये डेफिनेशन समझने में अभी थोड़ी भले ही ज़रूर मुश्किल लग रही होगी, लेकिन जैसे जैसे हम आगे जाएंगे ये डेफिनेशन को मैं और एक्सप्लेन करते जाऊंगा. ओके, सो बेसिकली ध्यान में रखना ये जो मैथमेटिकल एक्सप्रेशन दिया हुआ है, एफ एक्स ऑफ एक्स इज नथिंग बट प्रोबेबिलिटी ऑफ सम रैंडम वेरिएबल रिस्ट्रिक्टेड टू सम पॉइंट, nothing more than that. Okay, all right. So there are some properties of this distribution function which we needs to account. First is this distribution function capital F of x is always lies between 0 to 1. Okay, then f of x, f of some x is less than or equal to f of y if x is less than y. What that means, what these two properties are implying, that is all distribution functions are monotonically non-decreasing, that means they are increasing and always lie between 0 and 1. If f is distribution function of x and if a is less than b, then what it implies? It implies that probability of a less than x less than or equal to b is equals to fb minus fa. इसका प्रूफ भी है लेकिन हम प्रूफ में इंटरेस्टेड नहीं है. क्या होता है, पहले में स्ट्रिक्ट इनइक्वालिटी है, प्रोबेबिलिटी ऑफ ए लेस देन एक्स लेस देन और इक्वल टू बी. So what we are getting here, we are getting fb minus fa, function value at end points minus function value at starting point. ये कब, जब पहले a अंदर नहीं है इसके. नेक्स्ट पॉइंट इज जब a अंदर है और b भी अंदर है तो क्या आएगा, देन इट विल बी प्रोबेबिलिटी ऑफ a लेस देन और इक्वल टू x लेस देन और इक्वल टू b विल बी इक्वल्स टू fb माइनस fa. ये तो पिछली बार था ही, लेकिन अभी वो स्ट्रिक्ट इनइक्वालिटी अगर लेस देन और इक्वल टू में बदला है तो उसको x इज इक्वल्स टू a वाला ऐड करना पड़ेगा. सो इट इज जस्ट एडिंग प्लस प्रोबेबिलिटी एट x इज इक्वल्स टू a. थर्ड पॉइंट इज प्रोबेबिलिटी ऑफ a लेस देन x लेस देन b इज इक्वल्स टू fb माइनस fa माइनस, क्योंकि लेस देन और इक्वल टू b x लेस देन इक्वल टू b को स्ट्रिक्टली लेस देन कर दिया तो उसमें से माइनस भी करना पड़ेगा. सो माइनस प्रोबेबिलिटी एट x इज इक्वल्स टू b. एंड द लास्ट वन इज द मिक्सचर ऑफ द second and third. Probability of a less than or equal to x less than b is equals to fb minus fa minus p at x is equal to b plus p at x is equals to a. These are the some properties of distribution function which we should consider. Then important, very much important is this probability mass function. What is probability mass function? Probability mass function is very important topic here in this context of probability. What exactly it says? Let us see. Probability mass function and probability distribution of a discrete random variable. Suppose x is a discrete random variable taking countably infinite number of values x1, x2 and so on. With each full stop, with each possible outcome xi, we associate a number pi. What they are saying, we are taking x as a discrete random variable. I hope now discrete random variable is clear to you. Throwing a dice or throwing a coin twice or throwing a coin one times, basically one which is returning you a number, a discrete number, it is called a discrete random variable. We are taking x as one discrete random variable which is taking countably infinite number of values. DRV, discrete random variable, it may take finite values or countably infinite values. Okay, so no problem about that. So x1, x2 and so on, with each possible outcome xi, we associate a number pi. What they are saying, with each possible outcome xi, if we are associating a number pi which is equals to p at x is equals to xi. अभी हम लोगों ने p at x is less than or equal to xi देखा था पिछले definition में, which is also represented as p of xi, called the probability of xi. With each possible outcome we are associating that with a number and we are calling it probability. That we know the numbers p of xi, I is equals to 1, 2 and so on must satisfy the following condition. Probability mass function अगर p of xi को बोलना है तो उसने आने वाली दो कंडीशन सेटिस्फाई करनी चाहिए. व्हाट इज फर्स्ट कंडीशन? प्रोबेबिलिटी ऑफ xi इज ऑलवेज ग्रेटर देन और इक्वल टू 0 फॉर एवरी i. ओके, सो हर एक i के लिए लेट मीन प्रोबेबिलिटी ऑफ x1, प्रोबेबिलिटी ऑफ x2, प्रोबेबिलिटी ऑफ x3, ये इंडिविजुअली सारी की सारी नॉन निगेटिव आनी चाहिए. ओके, नॉन निगेटिव आनी चाहिए, मतलब जीरो चलेगा लेकिन निगेटिव नंबर नहीं आना चाहिए. सेकंड पॉइंट इज समेशन ऑफ ऑल द प्रोबेबिलिटी, समेशन i इज इक्वल्स टू 1 to infinity probability of xi. When you are summing up all the probabilities, it should come 1. This fact you already know, that sum of the probabilities should always be equals to 1. This is the same fact which we are discussing under the heading probability mass function. Then the function p of x is called the probability mass function of a random variable x, and bracket xi pxi for I is equals to 1, 2 and so on is called as discrete probability distribution. Because we are talking about x as the discrete random variable, hence it is called as xi p of xi is called as discrete probability distribution. So probability mass function, कोई function को होने के लिए उसको दो condition satisfy करनी पड़ती है, जो कि है एक it should be non negative and the other will be the sum of all the probabilities, the sum of all the numbers which we have associated with each possible outcome is 1. I hope it is clear. Okay, in the next class or in the next video, I am stopping here. In the next video, we are going to discuss the example on probability mass function. Okay, all right.